Hey everybody! Today we're going to be covering chapter 4. In this video I'm going to specifically focus on decision structures and Boolean logic and introduction to what those terms mean. Now these are all of our topics that we will cover today. And let's begin with the first one, Intro to Decision Structures. Now, Intro to Decision Structures is quite simple. So think of it as if something happens, then your code will execute. So we have a couple of different types of decision structures, but the one thing in common that they all have is the code that they represent will only perform under certain conditions. So only if something happens, only then an action will occur inside of your program. Now there are three different types of decision structures. The first one is, we call it if. Also, we call it the single alternative decision structure. So if something happens, do something. Now the other one, the next one, is the dual alternative decision structure, also called if then else. If something happens, do this. However, if something doesn't happen, do something else. And the last one is the multiple alternative decision structure, and that one just allows us to produce multiple different conditions for different pieces of code. Let's look at the if statement, the first one. So the if statement, it's simple. If something happens, perform some sort of code, execute some sort of code. So let's look at the flowchart equivalent of an if structure. The condition that you are testing to see if the condition is either true or false is going to be inside of a diamond. And the condition that we're testing in this example is it cold outside? If it is cold outside, we're going to follow the true arrow and we're going to wear a coat. However, if it is not cold outside, we're going to skip this whole piece of code and we're just going to continue carrying on with our program without taking the reroute to wear a coat. So basically what happens, if the condition is true, some sort of code will execute. If the condition is not true that we are testing, nothing will happen and we'll just continue with our lives when we are using the if statement. Now, let me introduce you to relational operators. Relational operators is this thing that we use to determine if either two values or two variables have a specific relationship between them. Now, these are all of the relational operators that exist inside of programming languages. They might look a little bit different from language to language, but the general idea is the same. So we have the first one is x is greater than y. So we are checking if x is greater than y. Then the next one is the opposite, if x is less than y. Then the other one is, the third one is if x is greater than or equal to y. Then this is a typo. Then this one is x is less than or equal to y. Then our next one is if two values are equal, is x equal to y. And the last one with the exclamation point is checking if x is not equal to y. So these are all fairly simple. You can take a screenshot of this table for one right here, table for one. You can take a screenshot and use it, put it in your notes or use it later when you're doing the quizzes and stuff like that. Now let's move on to the dual alternative decision structure. The dual alternative decision structure provides us with two pathways to execution. So instead of just going straight down and not executing anything if our condition is false, the way we did with our if structure, this makes us have two choices of where we should go with our execution based on our condition. So our condition in this example is if the temperature is less than or equal to 40. If it is true, we're going to follow this arrow right here, and we're going to display a little cold, isn't it? However, if it's not true, instead of just skipping this part as a whole, we are not only doing that, but also we're going to follow this arrow right here, and we're going to display nice weather we're having. So instead of just skipping the code that follows the true arrow and just continuing with the execution of our program, we are going to follow the false arrow and we're going to display something else. We're going to execute a different piece of code. Here's an example of how this will look with pseudocode. And remember, pseudocode is just fake code. that doesn't have any syntax, that doesn't have any programming language rules, so it's just plain English. So if some sort of condition exists, then perform these statements. However, if it does not exist, perform these statements. So this is the equivalent of the example that I just showed you. If the temperature is less than 40, then we're going to display a little code, get a code. However, if the temperature is greater than 40, we are skipping this piece of code and we're moving on to the else, and we're going to display nice weather and sunny. Most languages also will allow you to compare strings by using the decision structures, and all that you have to do most of the time is just use the double equal sign when you're comparing the strings. Now let me show you an example. You can either compare strings and strings, in this case name1 equals to name2, so we're checking if these two are equal. You can also compare the string variables and string literals. In this case, we're checking if the months does not equal to October. So it's fairly simple. You either use the double equal sign or you use the not equal sign to compare your strings. However, the only thing that you need to be aware of is the string comparisons are usually case sensitive, and what that means is if you have a word dog that is all caps and we're trying to compare it to the word dog, all lowercase, these two are going to be completely different. They will not be equal to each other. So whenever you're making string comparisons, just be aware that the comparisons are case sensitive. Now let's move on. Let's move on to the nested decision structures. Nested decision structures are the multiple decision structures which they just stack on top of each other. Just think of it as stacking Legos on top of each other. And as you can see, this looks pretty complicated, right? A lot of things, a lot of arrows, a lot of structures. However, if you look at it closer, it is not that complicated. So we're coming in right here. Let's look at it together. And the first condition that we're checking if our salary is greater than or equal to 30,000. If it is true, we're going to follow our arrow right here, and we're going to check our next decision structure, the nested. This is where the nested comes in. We're putting one decision structure after the other. And we're checking if years on the job is greater than or equal to 2. If that is true, we're going to follow our arrow right here, our true arrow, and we're going to display you qualify for the loan. However, if the first condition is not true, we're going to say you must earn at least 30,000. We're going to follow the false arrow and display per year to qualify, and then go towards the end of our program. However, if one condition is true and the second condition is not true, if the years on a job hasn't been more than or equal to 2, we're going to follow our false arrow, and we're going to display you must have been on your current job for at least 2 years to qualify. So this is how the nested decision structures work. Now here's another example of checking if the grades, which grade the student got. As you can see, we're just checking the scores and the values. So if the score is less than 60, we're going to display F. Score is less than 70, D, 80, C, 90, B, and then if the score is not any of these, that means that the score is from 90 to 100, which means that the grade is A. Now, there's also such as logical operators that are very useful with conditions and with decision structures. So everything that I showed you before, we just had one condition, right? We were checking something. We were checking either the temperature was less than 40, that is one condition, or we were checking if the salary is less than or equal to 30,000, which is also just one condition. However, if we have to check multiple conditions at the same time, this is where the logical operators come in. Now, there are only 3 of them, and, or, and not. The AND will combine the 2 conditions and will only return true if both of those conditions are true. Now, OR will combine the 2 conditions and will return true if either of the conditions is true, and NOT will just reverse the truth of the whole expression. So if your expression had been evaluated to false, it's going to be true, and if it's been evaluated to true, it's going to come back as false if we use our NOT logical operators right here. Here's an example. We're checking if the temperature is less than 20 and minutes are more than 12, then we're going to display the temperature is in the danger zone. Now, another example of or, if the temperature is less than 20 or the temperature is greater than 100, then we're going to display the temperature is in the danger zone. So as you can see, we're combining two expressions. This is our expression number 1. This is our expression number 2. So we're checking two conditions to see if either one of them is true, and if either one of them is true, we're going to display the temperature is in the danger zone. And here's how you would use not. You would use it on just one condition. We're checking if the temperature is less than 100, and then we negate that value, then we're going to display that this is below the maximum temperature. So as you can see, temperature is more than 100. For example, if we have a 96, right? 96, this will be evaluated to false, since 96 is not greater than 100. However, we have a not right here, so our false will be switched to true. So we're going to print this is below the maximum temperature. There is also such thing as short circuit evaluation. It is supported by many programming languages, and it will just boost your performance when it comes to evaluating your conditions. So what that is fairly simple. It is used with AND operators and the OR operator. With AND operator, if the expression on the left side that's going to be checked first, right? We have expression 1 and expression 2. So if this expression right here is evaluated to false, then we will not even check the expression number 2, because remember, when we're using the AND operator, both of the expression have to be true for the AND whole expression to evaluate to true. So if the first one is false, then we are not even going to check the second one, because the whole thing will automatically be evaluated to true. However, with the OR one is the complete opposite. So we have expression 1 and expression 2 that we're combining with the logical operator OR. If the expression on the left side, the first that we're checking, is true, we're not even going to check the second one, because remember that the OR operator only needs one of the expressions to be evaluated to true for the whole expression to be evaluated to true. So if the first one is true, we don't even need to know if the second one is true or false. This whole thing will automatically be evaluated to true. Now, also with the help of logical operators and OR, we can use them for range checking, to check if the number is inside or outside of the range. The only thing that you need to know is that if you want to check if the number is inside of a range of a certain number, you need to use AND right here, inside, and if you want to check if the number is outside of the range, you have to use OR. So for the inside is AND, for the outside is OR. And the last thing that we're going to cover today is the Boolean variables. And this is just an introduction to the Boolean data type. Boolean data type is a type of a variable that can either hold true or false. So the only two values that a Boolean data type can hold is true or false. This is all that you need to know. And in this example that we have right here, we are declaring a variable of data type Boolean that is called is lunchtime. And with the help of a decision structure, we're checking if the time is greater than or equal to 12, then we're going to set our Boolean variable lunchtime to true. And if it's not true, if the time is not less than, greater than or equal to 12, then we're going to set our lunchtime to false. So that is pretty simple. Let me know if there are any questions. Reach out to me. I'm always available to answer any questions. And I will see you in the next video.